Okay, so for k is equal to 7, 5k is 6. So we will make this table again. 1, 2, 3, 4, 5, 6, 7. So there are 6 characters. Let us say chi1, chi2, chi5, chi6 for n. As we know, first column should be all entries 1. These should be 0. Okay, now we know the entries for this second and fourth row, this elements 2 and 4, they should be 1 omega and omega square, because 2 and 4 are 2 and 4 have order 3. So these entries should be cube roots. So let us write, and we know sum of 1 omega and omega square is 0. So 1 omega omega square, and similarly 1 omega omega square. So sum of this column is 0. Now we have to differentiate between all these characters. So for this row, fourth, this, we can write this entry is same 1 1. So instead of omega, we write here omega square, and we write here omega to differentiate the values of chi2 and chi3. Similarly 1 here, omega square, omega. And now we know 6 is square root. These entries should be square roots of unity because 6 has order 2. So we write here 1 1 1. Let us say minus 1 minus 1 minus 1, because here 3 times 1 and 3 times minus 1, that will occur. Now for this row, we have these entries as 1 1 1, but here minus 1 only occurs once, so these should be minus 1 only to make this column 0. Now what are the other entries for these columns? Now here 1 and minus 1 are used, so the remaining entries for these two columns are omega, minus omega, omega square and minus omega square, and that we have to put so that these columns and rows all are 0. So let us put here, now here 1 omega omega square, this is already 0, but left is 1. So we have to put only omega and omega square in this row, and let us say we have put omega here and omega square here. Similarly in this row, 1 omega and omega square, they have occurred already, 1 here, so we can use the entries omega and omega square again in this row, but we have to use these entries like this, that this column also should be 0. So we have used omega here, so we will use omega square here, but omega square we have used, so we will use omega, so that in this column sum of these elements is 0. Similarly sum of these elements is 0. Now we have to make sum of these 3 elements and these 3 elements to be 0, and sum of these rows should be 0. Now the remaining entries in this row, they are minus omega and minus omega square. Similarly here minus omega and minus omega square. So if we write minus omega and minus omega square here, then sum will be 0 for this row. And minus 1 minus omega, so we have to put minus omega square to make this sum 0. Similarly we have to put minus omega to make this sum 0, and obviously this row now becomes 0. So now we can check this chi1 takes all 1 1 1, chi2 takes 1 omega 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 square 1, and so on. This 1 omega square omega omega 1, this is real valued, this is 1 omega minus omega, and so on. This, so all the characters are different, so we have to take care 3 or 4 things while making these tables. First thing, corresponding to 1 all entries should be 1. Second thing, corresponding to principal character all entries should be 1, obviously for the integers which are co-prime to k. Third thing, the integers which are not co-prime to k, all the entries are 0. Fourth, except this row and this except this row and this column, all the rows and columns should be 0. And one more important thing we have to take care, that if order of any element is n, then the entries in that column, they are nth roots of unity. So that's all. why that's all we have to care while making these tables. So now we have this theorem which says if chi1, chi2, chi phi k, these are distinct phi k Dirichlet characters modulo k, and m and n, these are any two integers, m and n, these are any integers such that n is co-prime to k, then we have this relation summation r varying from 1 to phi k, chi r at m and chi r bar at n. This is phi k if m and n are congruent to each other modulo k, and 0 if they are not congruent. So we know if m and k are co-prime to each other, then we take ai to be n cap and aj to be m cap, because n and k are given to us co-prime. If we assume m and k are co-prime, then ai, let us take ai is n cap and aj is m cap in the previous orthogonality relations, and we note that m cap and n cap, they are equal only if m is congruent to n modulo k. And in the previous orthogonal relations, we have proved this thing, that summation fr bar ai fr aj from 1 to n, this is n if ai is equal to aj, and 0 when these are not equal. So we are saying m cap and n cap are equal if and only if this. That means if we convert this relation in terms of Dirichlet characters, so it will become chi r fr bar at ai, it will become chi r bar at n cap, sorry, n fraj because fr bar ai means fr bar at n cap, and we know fr bar at n cap is chi r bar at n whenever n and k are co-prime. Similarly, chi fr aj, which means fr at m cap, this will become chi r at m. Now this is n, here is number of elements in the group, so it will be phi k here. ai is equal to aj means m cap and n cap are same, m cap and n cap are same if and only if these two are congruent. So m is congruent to n modulo k, and otherwise it is 0. So the orthogonality relation becomes this orthogonality relation in terms of Dirichlet vectors. And secondly, if m and k are not co-prime, then if m and k are not co-prime, then each term in the sum chi r m chi r bar n vanishes, because if m is not co-prime to k, then chi r m, this is 0. So each term in the sum vanishes, so this sum will be 0. And in this case, m cannot be congruent to n modulo k, because n is co-prime to k and m is not co-prime to k, so they cannot be congruent. So this summation will be 0. So hence prove this theorem.